Today's video is all about reaction stoichiometry. And the objective is that you will be able to perform stoichiometric calculations with 100% accuracy. To do this, we just need 3 simple steps. Step number 1. Convert grams of your given, which I'm going to use X to represent, into moles of your given. Step 2. Use the mole ratio to convert moles of X to moles of Y. And step 3. Convert moles of Y back into grams of Y. So let's go ahead and look at an example. How many grams of Ag are in 2.26 grams of AgNO3? In order to work this problem, the first thing we'll need is a balanced chemical equation. And I have that for you right here. So let's go ahead and identify what we were given in the problem and what we need to find. It says how many grams of Ag. So we know we're going to be looking for Ag. So I'm just going to put a question mark underneath Ag. And then it says are in 2.26 grams of AgNO3. So I know that I start with 2.26 grams of AgNO3. So we're going to go ahead and we have our T-chart. And let's take our given, the thing we started with, and put it in the first blank. Now, step number 1 said we needed to convert grams of our given into moles of our given. So let's go ahead and do that. To convert grams to moles, we divide by molar mass. And the molar mass of AgNO3 is 169.9 grams. And we know that that is per every 1 mole of AgNO3. Now, that gets us to moles of AgNO3, but the problem asks us to find grams of Ag. So we'll add another one. Step 2 says we need to use our mole ratio in order to convert moles of X to moles of Y. So the mole ratio, we'll get that from our balanced chemical equation. And I see a 2 in front of AgNO3 and a 2 in front of Ag. So I know that my mole ratio is 2 moles of AgNO3 for every 2 moles of Ag. I put AgNO3, 2 moles AgNO3 on the bottom because I wanted to cancel out moles of AgNO3 that's on the top. I'm still not done. I now have moles of AgNO3, but I want grams of Ag. So we'll add one more step. Step 3 says we have to convert our moles back to grams. And to do that, we're going to multiply by molar mass. The molar mass of Ag is 107.9 grams per 1 mole of Ag. And now we're going to solve. Multiply everything on the top, multiply everything on the bottom, and then divide. And when you do that, you'll find your answer to be 1.44 grams of Ag. Now let's look at a second example. Here's example 2. What is the theoretical yield of Na2SO4 that can be obtained from 7.470 grams Na3PO4? This one looks a little bit different because it says, what is the theoretical yield? Theoretical yield just means we're going to be finding the grams of this substance. So let's get started. Remember, step 1 is to convert grams of our given into moles of our given. The information given to us in the problem was 7.40 grams of Na3PO4. So let's go ahead and convert grams to moles. To do that, we need to divide by the molar mass. And this is the molar mass of Na3PO4. and that's per 1 mole. Step 2, we're going to use the mole ratio to convert moles of X to moles of Y. So moles of Na3PO4 to moles of Na2SO4. And the mole ratio comes from our balanced chemical equation. We have 2 moles of Na3PO4 for every 3 moles of Na2SO4. So we put 2 moles of Na3PO4 on the bottom to cancel that out. 3 moles Na2SO4 on the top. And finally, step 3, let's convert moles back to grams. So to convert moles to grams, we're going to multiply by the molar mass. The molar mass of Na2SO4 is 142 per 1 mole. When you do your math here, you should find the answer to be 9.702 grams of Na2SO4.